Okay, for my individual project, I'm going to be proving the statement that if n is a positive integer, then n is even if and only if 7n plus 4 is even. Now, before we get into our proof, I think it's important that we dissect this problem so that we actually know what information we're given and what we're actually needing to prove. So we're given that n is a positive integer. So this is something that we need to keep in mind that might be able to help us as we're doing our proof. We're given the information that n is going to be a positive integer. Additionally, when I'm looking at this statement, it is an if and only if statement. That means that I need to prove it both ways. Typically, we think about proof statements as being if P, then Q. But if I have an if and only if statement, I also have to prove if Q, then P. So I'm going to have to prove both ways. So we have our forward direction. Again, we're given the information. Let n be a positive integer. So we want to prove if n is even, then 7n plus 4 is even. When we're setting up our proof, the first thing that I like to do is just kind of start out with the information we are given. Start with your assumptions. So let n be a positive, even integer. We know it's positive because it tells us, and then we're going to assume that it's even. Then by definition of an even number, we know that n is going to be equal to 2k for some positive integer k. Thus, we can start to solve our problem. So we're going to start with the statement of 7n plus 4. And we're going to substitute what we know for n. Well, by definition, since n is a positive even integer, we know it's equal to 2k. So you can see right here where I put my 2k in for n. My next step, I'm just working through this algebraically. I'm going to distribute that 7. So now I have 14k plus 4. Now, in my mind, I'm thinking that I have to convert this to an even number somehow. I have to put this back into that form 2 times some positive integer. And so what I'm going to do is actually take out a 2. I took out a 2, which leaves me with 7k plus 2. And this is helpful because I can reduce this 7k plus 2 to the variable L. So now I'm going to say that I have 2 times L, where L is equal to 7k plus 2. And I know that L is a positive integer. Well, this has just helped me out because now when I'm looking through this, I started with the assumption that n is even. So what I needed to prove was 7n plus 4 is even. And I put that 7n plus 4 into an even sort of notation of 2L. So I can conclude my proof by saying, hence, we conclude that when n is even, 7n plus 4 is even by definition of an even number. Now, it's really tempting to stop here. However, we can't because remember, our proof, our statement that we're trying to prove is an if and only if statement. So we've proven the forward direction. Now we need to prove the backwards direction. Okay, so before we get into our backward statement, I want to expose ourselves to a technique that I'm going to be using. It's called proof by contraposition. We might have heard of this, maybe not. I just want to make sure we're all on the same page. So this is a technique for proving conditional statements in the form if P then Q by proving the logically equivalent contrapositive statement if not Q then not P. This is a really vital proof technique that helps us solve some of these more tricky proofs. If you don't believe me, if you're not taking my word for it, I do have a membership table below that shows this logical equivalence. So again, I'm given the information. Let n be a positive integer, and I want to prove the reverse statement. If 7n plus 4 is even, then n is even. Now, looking at this statement, this is really hard to directly prove. So I'm going to use some of my other proof techniques so that I can make this a little bit easier for myself. If I'm going to do that, I have to state to the reader what I'm doing. So let's prove the contra positive statement. If n is a positive odd integer, because what would be the opposite of even? Odd. If n is a positive odd integer, then 7n plus 4 is odd. If not q, then not p. So, assuming this, then by definition, I know that n has to equal 2h plus 1 for some positive integer h by definition. When we know we have an odd integer, it's going to be in the form 2h plus 1. Thus, I'm going to start with my 7n plus 4 and see what I can't figure out. I have 7n plus 4. I substituted the n for my odd expression. 7 times 2h plus 1 plus 4. What am I going to do next? I'm just going to attack this algebraically. I'm going to distribute that 7. This leaves me with 14h plus 7. 7 times 1 is 7 plus 4. Now, again, I'm thinking I have to somehow put this in an odd form. So I know that I'm going to need a plus 1 on the end. So instead of adding 7 plus 4 to equal 11, I'm going to break this up into a 10 plus 1. That is the same thing. I'm just manipulating my numbers. Because now what I can do is I can pull out that 2 from my first two terms. So 2 times 7h plus 5 plus 1. This puts me into my odd form because now I can just describe this to the value j. I have 2j plus 1, where j is equal to 7h plus 5, and j is some positive integer. This is what I want to do. You envision where you need to go, and you make the form that you need. So I've just shown now that when n is odd, when I make the assumption n is odd, 7n plus 4 also leads itself to that odd form. So I can conclude. Hence, we conclude the contrapositive statement that if n is a positive odd integer, then 7n plus 4 is odd by definition. We already proved that the contrapositive statement in the preceding slide is logically equivalent to our original statement. So honestly, we can end the proof here. And to end that proof, I have my square to indicate that I am done with this proof. Let's reflect on the statement that I was proving at the beginning and make sure that we covered all of our bases. So I wanted to prove that if n is a positive integer, then n is even if and only if 7n plus 4 is even. And I did this, I accomplished this. I did the if and only if statement. Each time I let n be a positive integer, and then I prove the forward situation. If n is even, then 7n plus 4 is even, and I prove the reverse statement. If 7n plus 4 is even, then n is even. Remember this reverse statement. I did use a contrapositive statement, but we know that this is logically equivalent. So I have proven the statement shown.